So hi everyone. In the previous video, we were discussing how we can solve this, write a code and write the logic for solving this anagram. And we discussed, the dictionary-based approach, and it's a really efficient approach with the time complexity and space complexity both of O of n. So there is one more approach which let's try out the approach. So for example. Let's call this solution 2. Okay, and this is based on sorting. So we'll see how we can use sorting and also solve this problem. So let's take the same two words. We have apple, A-P-P-L-E, and A-E-P-L-P. What we are going to do is sort both of this. So if we sort this, what we'll get is A, E, uh, L, and P and P. And if we sort this one, again we will get A, E, L, P, and P. Okay, so this sorting will take some time. It will be, say, if I am taking a quick sort and log n, this is the time for sorting, but it makes the problem easier. So once we have sorted, we will, move a pointer over the length. So we'll move two pointers. Let me use a different color for here. So we have two pointers, one on word one and another on word two. And we'll check whether the character one of this pointer and character one of this pointer are the same or not. Then we move next. We move here. We check whether they are same or not. They are same, then good. So anywhere we find, sorry. So again we go for L and we check whether they are same or not. P, P, so they are same. Had it been some other words, say instead of apple, it was you know this word four, so it would have been A, E, K, so it would have been this only. Okay, so we would have checked, okay, A is same, E is same, but here it's L and here it is K, so it's not same. So as soon as we find a dissimilar character, we'll say that it's not an anagram and we'll break out of it. Okay, so this is yeah, that's the algorithm actually, pretty simple. So here, if you see the time complexity, one is for sorting this two, so it will be O of n plus, like, for sorting this one, and then for sorting another one, it will be again O of n log n, and then plus it will be we'll just loop once over the number of, like, we can have a pointer, say I, from 0 to length of this, and for each of that index we can pull character from both the words at once, so we need not create two separate loops. So here we'll have O of n. So you can see it's yeah, costly, but overall the approximately it comes out to be O of n log n. Okay, and space will be again often. So how? Because this is a string, we cannot it's immutable, we cannot do it in place, so we have to create some another, say, list of this sorted elements, sorry, this sorted elements in a list. So this will take O of n, and for again this one we have to create a sorted, so this will take O of n. So our space, our space complexity here will be O of n plus O of n, sorry, O of n, which approximately becomes O of n. Okay, so this is the solution. So let's code it out again. So let's see how we can do it in Python. So again, define, say, check. Let's not write a function. Okay, let's try define check. I'll just simply copy this one. Even this one will be the same. So here also, we can do the first thing is to check the length of the both. If they're not, then we can simply return false. And then what we can do is if this condition is satisfied, then we can do, say, sorted word one is equal to, there is a inbuilt function for sorting here, word one, and sorted word two is equal to sorted uh, word 2. Okay, now we'll simply loop for I in range of length of say word 1, and at every index we'll then grab both the letters. We can also zip actually, so either we can do this, say if sorted word 1 of I not equal to sorted word 2 of I. If in any index they are both not same, then we simply return false. Else, we come out of it and we return true. Okay, so let's check this. Let me copy the same thing here, same checks, and let's run this. Let's see what we get. So yeah, we get the first two words, they were, apple and elab, they were true, and false, false. So this works out. This works out pretty fine, but again, it's a bit costlier in terms of time because of this sorting operation. But this is one solution, just I wanted to show you that, yeah, this is possible. Here you can, write a zip function as well. Like this is an interesting way you might be knowing. Just for the sake of showing, also suppose we comment this out, and we can have for say character 1 comma character 2 in zip of sorted word 1 sorted word 2, and we can check if character 1 not equal to character 2, then simply return false. Okay, this is also possible, and if we run this, we get same thing. Okay, so here the time complexity is as I said, this one is O of n log n. This one is again O of n log n. So we'll, this one is O of n log n, and then looping over once, this is O of n. So n log n plus O of n. And space, this two new list which are created here. Okay, it's inside function, but yeah, these two lists which are created here, the sorted word 1 and sorted word 2. So you can check here. Okay, if I just run it outside, just to show you that this list is created. So yeah, for this it will be O of n plus O of n. So that's the space complexity. Okay, I hope yeah, you got to learn something, and thank you for being, and till then be safe and take care and keep learning. Bye.